Yo, 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 yo. Dropping in with a short midweek stream. Good morning, Derek and Ami. It's been a few days since my last stream. I've been busy, unfortunately. What's up, DDG? But if I remember correctly, we were implementing, or rather re-implementing, the fluid solver. Basically want to remove everything we don't need so we can do a proper performance test, because I need to know roughly where we stand, like roughly what time are we gonna need in game for the water to solve itself. And let's see here. Okay, so this is the old implementation. Relies a lot on custom classes and stuff like that, and that's what we're trying to remove this time around. We will try to work with the texture data directly instead of storing it in temporary structs or classes. Yeah, I think it's been 5 days since I last checked this code, so gonna take a few minutes to get back in it. But yeah, okay, algorithm step 1, finding all reachable minimas. That's what we should focus on first, and that's what we're trying to do here. So yes, and compared to the old solution, where we created fluid point bytes and filled up the neighbor nodes continuously, we don't need to do that this time around. Instead, getting the neighbors for a point is going to look something like this. And it's all about, let's take a look at step 1. So we have an array, unvisited nodes. We remove the first one there. We keep this one sorted, so the node with the most water is the one first at all times. So we remove the first one, and then we disperse the water to the neighbors. And we check if it's a minima. If it is, we add it to minimas. And yeah, if we're able to add water to it, we add it to unvisited nodes as well. So yeah, it's pretty much a flood fill. But this time around, we won't have functions like this, or we're gonna have to re-implement this one in a better way. But we won't have functions like this one and this one. So let's see here. Instead, we have a point, and look at this. Beautiful. We have a point that is described by which terrain patch it is and the X and Y indices. And that's what we have to work with. We have a get terrain patch here, because if we move in the X or Y direction of a terrain patch, there might come a time where we move from one terrain patch to another. That's why we have this function here. And we also send in, so this is a function that returns true if we have a neighboring terrain patch, false if terrain patch is null. So if this one returns true, we know that we have a neighbor here. And if we have a neighbor, it's time to add fluid to it. Depending on if that succeeds, we add it to unvisited nodes. It's basically two methods involved in this one. It's first of all, it's this one, get fluid spread cost. So in the old solution we had a method where we send in some variables, we get the cost of like how much fluid are we removing when we move to this neighbor, and then we add so-called finding minimum fluid to this point, and we add whatever we have in this point minus the fluid spread cost, and we also check if it doesn't already contain it. Okay, it's slowly but surely getting back to me exactly what's going on here. Okay, so not entirely sure I want to do it like this, get fluid spread cost. Instead, I would like a method that basically calculates, given a fluid amount, it calculates how much fluid that travels to the next point. There's a lot of things to keep in mind here. So we have have you considered with things like and cost check maybe reversing if the cost of the logic check is cheaper from to write? So you mean this one, right? And yes, I have. So sometimes, like if you have it like this, you want to do the check that is going to complete or fail the most often first, because if we have a double and, if we have an and this one succeeds, then we don't do this check. Yes, but the thing we have here, so yes, I have thought about this, and we still want to do this. So even though unvisited nodes contains this one, we still want to do this one, because unvisited nodes might get more fluid from a different node than it did from its first one. So the first time we flow to a node, like it's been a lot back and forth, because that should not happen if we write the algorithm in the correct way, but there exist a few like the idea why this one is first here is because we might add fluid 2 times to a node. But that's also a thing we want to rework, because if we do the algorithm, like if it's possible to do the algorithm in such a way that that's not a scenario, then we wouldn't need this one, so to speak. But we had one example. Let's see if... Yeah. I think the scenario is... Okay, so what we're doing here is we're spreading water over a grid, basically. And depending on if we spread it based on fluid amount, so the actual fluid that is at the point, or if we do it on fluid surface, depending on which one of those two we choose, we need to have this one. So if we go by actual fluid amount and we always travel in the way that has the most fluid amount, we might get to a point where at that point we get a fluid height of, or we fill it by a small amount of fluid, but then we, from another direction, we flow downwards a lot. We don't have as much fluid amount, but we have a higher fluid surface. And then when we get to this point, we might actually get a higher fluid surface. I think it's that. It's all quite complicated, to be honest. But that's why we do it this way. Yeah, like the order of booleans in logic like this, like it's one of the first things you learn, right? Like if the first one decides you don't need, it doesn't do the second check, so keeping in mind which one to have first, even though it's quite basic, sometimes I can miss it. I'm not that familiar with, so that the add in the function means it implies it's a destructive function. Not entirely sure about the destructive function terminology, but this one might succeed. It might also fail. But yeah, so like this function, yes, it alters the object itself, or the data in the object itself. Yo, what's up, Fabic? Good morning. I think in C++ a lot, and you would know from the function being const or not. Yeah, but that, like, definitely something to keep in mind, to think about. Checks like this. I think we have another case where, yeah, so for instance, let's see if yeah, this one for instance. This one for instance, here we have that in mind. So is minima, here we just check, is this point a minima or not? But we don't need to check that if minimas already contain it. So here we have ordered them based on this one is decisive. Contains should be a const. But contains is not the function I've defined? Or what do you mean? Contains should be a const, as is minima. So it's about thinking which is fast to check first. Yeah, but this one is not a constant. Like, we don't know if like this is lazy as well. So we don't know if a point is a minima until we have done a lot of calculations for that point, and we don't want to do those calculations for a point if it's irrelevant. Sorry, I'm just leading you down the proverbial garden path. No, I love that path, man. It's just, I'm just wondering if you're correct or not. Like, we want to lazily check, but does is minima require contains first? So minimas is a list of points that are defined as minimas, okay? This list gets filled up continuously as we walk down this grid. Is minima is a point is a minima if the points is the height is lower than all its neighbors and it has at least one neighbor that has a bigger height. And we don't want to check this for all points, right? So this is lazily set, which is going to screw me when we re-implement this method because we might not be able to do it like that then. So it's first when we ask if it's a minima that we calculate if it is a minima if we haven't done it already. Like the only thing we do here is adding it to the list. So if this one is true, we add it to the list. But if it's already in the list, then we don't even need to do this check. So, like, I would say this is the best way. I'm having a hard time arguing for it not being the best way. As to contains should be a const, I don't know what you mean there. Contains should be a const. Like, this is not the method we have defined ourselves. I appreciate it. We're gonna need a lot of that. I'm gonna need a lot of that in the next steps. So I'm also thinking here okay, so once again, compared to the old implementation, we used a custom class. This time around we use tuples. I'm still wondering if what's the best approach? Fabric, yeah, that sounds weird. I think all my graphs and stuff show that I should be sending with video as well. Like in this case, I wonder if when we define a neighbor here, we might as well have it like a tuple like this from the start, like this. But I don't know. It's fine now, the video was blank, yeah. Technology, right? I wonder if we just want to define it like this, and here we do terrain patch. I wonder how this would work. It should probably be fine. Get terrain patch. I don't know how. It's not as readable, but I guess it's still readable. Good morning, Wesley. I don't know, reopening YouTube helped. Nice. I'm still surprised on a daily basis how many times you can solve something by just restarting it. It makes sense, I suppose. So what are we up to today? So I think my last stream was last Friday, and we're pretty much just at that point today as well. So it's about cleaning up and rewriting the fluid solver in a hopefully less data way. We want to remove the fat, so to speak. Okay, so we get the correct terrain patch, and what we want to do then is spread fluid to neighbor. Yeah, that's what we're gonna do. And I think we're gonna do it like this. Let's see here. Spread fluid to neighbor. We're gonna work a lot with these tuples. I don't know if that's the correct choice. I almost always prefer custom classes, but it's a little bit of a at the same time I want to avoid it. So spread fluid to neighbor. We want to send in P, and by P we get the fluid. We want to send in N, and then we want to send in some rule set, like the costs we have. And this is also a thing we're gonna do when we redefine the fluid solver. We're gonna get to it. I mean, the USA doesn't work. Have you tried unplugging it and plugging it back in again? Feels very in time these days. Damn, how are you going to refactor this to GPU processor? What a nightmare. Yeah, that is going to be very interesting, I think. First of all, we have to... like, that is the next step. In that case, we're going to have to see... We're going to have to analyze this one and see where we can... which part of it that is easy to redefine as in parallel. It's going to be interesting. Wesley, you know the game Timberborn? No, I don't. Oh, is it like city builder about beavers? Yeah, there we go. I can imagine that involving a lot of water and rivers and waterfalls. Very nice. I'm gonna check it out. Fabic over on YouTube knows what it is about. Beavers. Have you played it, Fabic? And since you're asking, Wesley, I imagine you have played it. Is it enjoyable? Yeah, beavers, extremely productive animal, are they not? That's the image I have of them. But it's pretty much based on child stories. Entirely based on child stories. No, but it's from a Polish developer. Okay, interesting. Wesley, they have droughts, so the water is dynamic. I played it a little, not too complicated, but a nice twist on city builders. Yeah, it sounds like it. like real-time dynamic water. I don't know if they have that in that game, but like that is extremely interesting. But I know that we can't have real-time dynamic water in this game. It will take way too much. I don't think I have the computational power to spare for that part of the game. It's not... the water isn't in focus, so to speak. Not as much as in a game about beavers, I would imagine. Okay, so when I'm talking about cost of spreading the water, previously we solved it, or I'm gonna take the blame for this one, solved it in a pretty basic way. So we pretty much have this. If height is bigger than p height, i.e. we're flowing downwards, we have a cost of 0. This I want to change. If height is less than p height, i.e. we're moving upwards, then we have a base cost plus the amount we're traveling upwards times a upwards multiplier cost. And if we're moving parallel to the ground, i.e. p and neighbor height are the same, then we only have a base cost. Extremely simple, and I think a lot of the pros and cons of the algorithm can actually be derived to this method. Like, this method actually has a lot of power as how the output of the algorithm looks and plays. And initially now, I don't think we're not gonna do... One sec, be right back. Okay, back, sorry about that. Let's see. Yeah, it flows through the rivers, etc. I get that. Figure it might help with figuring things out. You're definitely gonna check it out. Like, I enjoy seeing how other games solve problems in general and related problems or specifically. So thank you for that one. Oh, and Fabic on YouTube always also says that there is a post-mortem video on YouTube on their water system, so definitely gonna check that one out. Need to put it in my note book. And I've been known to take inspirations from different places. And also when it comes to post-mortems, it's not like they give you the code. So you're still gonna have to fully implement it, see how you can bend the rules to fit your use case and so on. Always better to learn exactly how your systems work. Almost always. Otherwise, you're eventually gonna run into a problem or a specific thing you want to implement, and you're gonna have to do it anyway. And the water in Timberborn isn't that dynamic, Fabic said. Yeah, I can imagine it being something like this, offloading calculations to a second place, finding some form of stable state and then visualizing that stable state. Yeah, definitely gonna check out that video. But get fluid spread cost, extremely important function, currently extremely basic. We're gonna keep it as basic as this, but I wonder. We're gonna have a base cost. Like, there exists multiple ways we could do this more complicated as well. So this one is, it has no memory, right? This one only keeps track of what the previous node has and what the new node, what the water from the previous node to this node should cost. It doesn't have any memory. One could think that a solution where it also has some sort of memory would be nice. For instance, if the base cost here on moving in parallel could become more and more costly depending on how many times the water has flown parallel. And I'm always thinking about different ways to make this one more, how one can extend this one to be as powerful as it actually should be. Wesley, I mean, games are always smoke and mirrors. Yeah, almost always, right? Maybe consider writing cost functions flat so early returns don't require an else. So how would that look? I'm me. So you want to check if they are equal first. So you pretty much just want to do this. We could do, yeah, we're on to something. Let's see here. It's a C thing. Fuck, I learned C, I learned C after already been programming with object-oriented languages for 4 years. And going back to a language without objects, as I remember it, was a pain. Let's see here. Terrain fluid solver, that's the new one. So spread fluid to neighbors. And the question is... Yeah, we probably want to do it like this. We're gonna have int base cost. Do I want to do base? Int cost upwards cost up, cost down. p height, p fluid. Yeah, we're gonna see if we can make it work. I think we can do it like this time around. So let's see here. Get data. We're gonna do int. Do int cost is equal to cost base. And then we're gonna do int height difference is equal to p height minus n height. And then we do, so if p height is bigger than n height, we're moving downwards. We're gonna do, yeah, here's a big question though. Do I want to include cost base here? Okay, we're gonna have these three, but initially we're gonna do it exactly like we're gonna do it we're gonna implement it the same way we did in the previous implementation, just to make sure that when we test it, it yields roughly the same results. And I say roughly because there might be some differences. Yeah, so here we want to do height differences times cost up. Yes, the difference between this method and the previous one is that this one is also going to spread the fluid itself. So in the previous implementation we had one method for calculating the spread cost and one function for adding it to the point. That's not how we're going to do it this time around. So we're going to have to rely on, we're going to do something like this, n dot n fluid is equal to p fluid minus cost. And then we're going to have to rely on n terrain patch dot terrain data set data, but yeah, this is very interesting. So this, what I'm trying to do now, I like the idea that a method only has one purpose, but sometimes it might be too fragmental to go that path. What I'm doing now is I try to isolate the adding fluid to this method, because later on we're gonna have to, so when we extend this one to add more logic when it comes to altering terrain that already has water or adding water to a place that already has water, I want to isolate it to this method pretty much. So although we go with nTerrain patch.terrain data set data this time around, this will probably change to add data eventually. And also, yeah, we're gonna do it like this. Terrain data type water temporary. Apply false. So that's the default. Because now we're continuously altering a texture as well. And we don't want to send that texture data to the GPU until we're actually going to use it. So in this CPU case, it's going to be when algorithm step 1 is done, that's when we're going to send all the data to the GPU, and we're going to render some stuff while we continue doing some calculations on the CPU. I'm just waiting for Mrs. Streamer to get rid of that link. I love link. But yeah, performance-wise, it's debatable if it's worth it. But, so, on that topic, in the previous method we did this. So, when we got a neighbor and we added it to unvisited nodes, we added it at the end, and then after we have gone through all the neighbors, we reorder the list. The question is, what is the best way? Is it adding all to the end and then reordering it? Or is it adding it at the correct position from the get-go? Depends on how often this one comes through, I would say. Okay, so spread fluid to neighbor. Returns true if we succeed, false otherwise. So set data here. We need to figure out, did the data actually change or not? We can do it like this. And fluid new. And we can do int and fluid. Although yeah, later on, like between the steps as well, we're gonna have to do something. We're gonna have to clear this data. So basically between the step, we also want to take whatever data we have in water temporary, we want to take that and move it to water channel. So it's basically going to be moving the data we have in channel G to channel R. We can probably do that in a smart way. We'll see. But I think we also want to do this. If n fluid new is bigger than n fluid, we do this. So given a tuple p, terrain patch x and y, and a tuple n, terrain patch and X and Y, a base cost, a up cost, and a down cost. We calculate the cost, and then we figure out the new fluid that should be in N based on this information. We check if that new fluid amount is bigger than the current fluid amount. If so, we set the data and we return true. Otherwise, we return false. I think this is pretty nice. So, if spread fluid to neighbor, here we want to have P, N, and then we want to have cost base, cost up. And this is where we're going to have to introduce some cost variables, some constants. But yeah, want to be able to alter them easily and quickly from the editor. So let's see. We're just gonna go with and we have different stage. I think we have a total of 3 different stages here. Want to name them, like, I actually want to have a better name than we previously had, but I don't think, I'm not so sure we have a better name. So here we have the different stages of the algorithm are named after roughly what they do. So finding minimus is the first stage. So then we have finding minimus base cost, finding minimus up cost, and I think that's what we're gonna go with here as well. So finding minimus cost base and cost up. By default, we're just going to go with 0, 0, and 1, I think. So, spread fluid to neighbors, finding minimus cost base, finding cost, is it up? And finding minimus cost down. I wonder if we're gonna do it like, let's keep it like this. And unvisited points contains n. Although this is by value, right? Yeah, we might get some problems here. Comparison. Tuple equality. Output true. Okay, nice. This is beautiful. This is what we want. Although okay, interesting. Yeah, but I think this works in our case. Reference. So if they reference the same terrain patch and X and Y coordinates are the same. Fabric, I bet you could write a better job that does the same thing as Link. I don't know if I want to go down that path. So the only thing we want to do here is unvisited points dot add n. And then we're done with step 1, I think. Yeah, we want to figure out if they are minimas or not as well. That is true, but how can we do this in a better way? Yeah, we have final points here we want to work with. Fabi, hey, you do you. I'm just giving suggestions. I appreciate it. Might do. I can imagine it being an interesting adventure. But I mean, I wonder, I'm also interested in how like Link gets continuously improved, right? I wonder how much of the critique it gets is based on old implementations and how much is still valid today, if you know what I mean. Terrain patch, get terrain patch, spread fluid to neighbor, true or false. If it's true, we add unvisited point. We add it to unvisited points. Actually, back to what me was saying. Like even if we contain this one, we might still want to add fluid. So we're gonna keep it like this for now. I wonder if it's worth a note, however. Or I want to explore if unvisited points dot contains is actually necessary. Like, I guess it depends a lot on how we set up the base costs, the up costs and the down costs, and yeah, how the spread fluid to neighbor is actually implemented. Like if we always follow the most fluid amount, so we always walk in the path of the most fluid amount, will we actually get to a case where a point gets more filled by its secondary path than its first one? It's worth thinking about. But okay, so in this first step we have the is minima left. And the question is, and also, insert at the correct place or sort after all neighbors has been visited. I don't know. So this one is left. And then also, I would also like to implement or transfer this method from the previous implementation to this new one. I still want to be able to visualize this one, but with a bit more options maybe. Okay, so is minima here. We might get to a point. Here it is. So is minima. We want to check, like here we're accessing all the neighbors anyway, so we might as well include the minima calculation within this one. Which means that we're not going to access the neighbors more than once for each p, but it also means that our check this time around won't be as lazy as the previous one. So worst case scenario, we might actually calculate a point being a minima multiple times. But once again, this one, if contains, if we can remove this one, that also means that we won't calculate minima more than once for each p as well. Just to make this like 100% sure, like 100% crystal clear, it's what I'm afraid of is that we might take a point that is in unvisited points, we spread its fluid to different neighbors, but later on in the algorithm this point might be added once again in unvisited points, and yeah, it sounds dumb and we want to avoid it, but it's dependent on this. So to check a minima here, we basically want to take fluid point, it doesn't matter which one. We pretty much want to take this logic and we want to bake it into the double for loop. And it should be pretty easy. One thing. Yeah, okay, this sucks for... Yeah, we're gonna have to get this data again. So this one and this one and this one, we might actually do outside of this method and just send in height difference. Because if we want to get to the bottom of the repeating question, is it a minima, we need the heights to work with. We also have the case where, which I haven't handled right now, which is when we get terrain data, get data height here, we haven't Let's see here. Yes. Oof. We haven't wrapped these coordinates. So when we move from one terrain path to another, we actually need to wrap the x and y. Because if we move from the last index of one terrain patch, we're going to get to the first index of another terrain patch. And we're going to have to handle this in two different ways. So first of all, it's the straightforward one of handling it here. Just wrapping the indices. And then it's also the fact of when we walk from one terrain patch to another terrain patch, we're actually walking from the same data point to itself, because neighboring data points in patches represent the same data. So when we move from one patch to another patch, we also want to make the fluid cost 0. So it's two things we're going to handle. The second one I brought up, we're going to wait with that one a little bit. The worst case, by not implementing that one, is a little bit of a difference between two water patches. But the worst case of the first one I mentioned is a null point error, or trying to fetch data that doesn't exist. So that one we definitely want to handle. How do we want to handle this? Because this one relies on these one being unwrapped. So we could do it like this, and then we're gonna have to do n.x is equal to n.terrainPatch.get index wrapped x n.x, n.y, n.terrainPatch.get index wrapped y. This one pretty much solves two problems. So, or solves and solves. It solves one problem and hides another problem. So imagine going from one terrain patch to another terrain patch. So then we wrap the index from, so for a patch that is 16 times 16 data points, we wrap the index from 15 to 0. So we add 1 to 15, we get to 16, but that's above our limit, so we wrap it around to 0. But it also solves the problem of actually, let me think here. Previously, when it comes to height and such, it also solves the problem of going outside of a terrain patch and there doesn't exist any data there, so we just grab the data from itself. I wonder how that will look when it gets to water. I think it's pretty okay. I think we want to do it like this. Also, I'm also wondering what exactly is happening behind the scenes here. Are we redefining? Would it be better to do n is equal to n dot terrain n dot terrain patch n dot x, or p dot x plus I p dot y plus j. Would it be better to do this? Because then we definitely don't want to do it like we define it once here. Then we create a new one here, 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 create a new one here. It's rough. Pretty sure we probably do. Pretty sure. Okay, so back to the minima. This check we don't care about. Okay, so we want to set it to false first. For each point we want to either set it to... Okay, so if this happens we don't want to check it anymore. That's unfortunate. Yeah, okay. So I wonder, we want to set it to true. If it's false we don't want to check this anymore. Yo, what's up, Little Miss Murder? I hear you. How's it going? It's going pretty good. I think we're moving forward in a chill way today. We're taking it slow. So, as soon as we find a neighbor height that is bigger than p height, then we know that we don't have a minima. But this one also needs to be set. You have a fence post error. One of your tests must include equals. I don't think so. Like, this is a method we know works. I'm not saying I'm 100% sure this is correct, but are you 100% sure it's not? So what this method does is we want to check that, listen to this, we want to check, given a point, we want to check that it has at least, that its height is at least less than or equal to all of its neighbors' height, and at least one neighbor has a higher height. That's what we want to do in this method, and I'm pretty sure that that is exactly what we do, and that we don't have a fence post error. But I would appreciate being proven wrong. You're not testing for equals. Yeah, because we don't want to test for equals. Like, if it's equal, if a neighbor's height is equal, we don't want to do anything to isMinima. Then we just want to keep it as is. So we are implicitly checking for equals. It's just that we don't want to do anything for equals. Like if the height of a neighbor is the same as the point's height, we don't want to set isMinima to false, and we don't want to set it to true. We want to keep it as is. Yeah, the default is false. Because if you have a point where all the neighbors are the same height, then it's not a minima. We need to have at least one neighbor that has a bigger height. I just needed to understand whether that was the desired behavior. Yeah, like I appreciate like pointers like that, definitely. And I'm also a little bit intrigued, like by people that are extremely certain. Like, believe me now, I'm not trying to say this in a bad way, but like, when you entered the chat, you didn't ask any questions, you just stated you have a fence post error. Like you made this statement. And when I see something like that, I get taken aback a little, like, oh, maybe I do. So I'm hearing you out, but like with the certainty you entered the chat with that statement before you understood. No, it's okay, it's okay. It's just I find it interesting. And like once again, I also want to say that it's not that I'm getting annoyed. I'm definitely not. Like I appreciate pointers and information and stuff like that. So don't let this hinder you from doing it again. It's interesting. Yeah, you did. I appreciate it. So yeah, like this is also a reoccurring point, or has been since we first introduced the term minima here. Like I've been getting a lot of questions about it, and I don't know if our definition of it or my definition of it in this use case is crystal clear, or if I'm making things harder for myself, but it was the best way we could define it, or easily define it. So we're working with a height map of a terrain, and we want to find points where water can actually collect. And it just felt natural that a point where all the neighbors has a bigger or equal height, and at least one of them is bigger. But this is definitely up for debate. Samsmite, hey Robin, tried Godot before. Good morning, by the way. Yeah, I have, but I have like, I'm one of those people that, so side note, I like to keep track of how many hours I spend in softwares and games. So, and Steam is extraordinary when it comes to that. So if something exists on Steam, I get it on Steam. And I have Godot on Steam, and I have tried it but I think I'm just at 4 hours maybe. So yeah, I know nothing. Okay, so we want to take this method and we want to bake it into the double for loop here. Right, and this is going to be... Now we can't rely on not doing anything for equal height, I don't think. So now we have to be very cautious that we get all the outcomes. Because we can't do an early exit like this one. And we want this one to override this one. Yeah, we basically want this one to override this one, and we want this one to override this one. So this is, it's gonna be a mess. One could, I think we're just gonna do it like, let's see here. Actually, we never want this one to override this one. So could we do is minimize equal to true? And then we want to send in I think we want to send in both of these. Actually, not fluid, but height. And this one, we can put this one up here instead. P height, remove. So we just grab N height here. And we need to send it in here as well. Height difference. Can we wait with this one as well? No, we cannot. So if height difference is bigger than 0, cost 0. If height difference is less than 0, so we do it like this instead. Fabric, sorry for the distraction, but have you had time to watch that video I sent you? No, I've like, if I remember, it was the last video you sent when we talked yesterday, and like since I got up at 6 this morning, I've only been working pretty much. Little Miss Murder, I troll a bit on Google. On topographic maps, lows and highs are called depressions and elevations. Oh, respectively. So lows are depressions and highs are elevations. Probably more descriptive than minima and maxima given the context, but you're not writing the code for someone else to maintain. That is true. That is also true. I appreciate it. But I wonder, so when we talk about topographic maps, when we're talking about elevations, isn't that when we're moving from one point to another and we're moving upwards, and a depression is when, like, the inverse, so it doesn't really have, it's not really a minima, if you know what I mean. So what I'm trying to get at is, or actually, I wonder if it's from all directions. So an area, so if we're in a topographic map, if we're in an area where moving outside of that area moves us upward, that means that that area is a depression. And if we're in an area and going outside of that area moves us downwards, that's an elevation area. And I would love, like, if I could make my algorithm depend on elevation areas and depression areas instead, that would be amazing and would save so much time. Like, if we could in some way, we should be able to, if you could define, like, a data of the terrain that keeps track of different groups and which points are included in which height groups and such, you could do so many beautiful things. But Fabric, I will. Hopefully the next time you ask, the answer to that question will be yes. Samsmite, your clickety-clack keyboard just reminded me of buying myself a new keyboard. The current one is good for gaming, but very cumbersome for coding and typing. Relatable. I actually have that on my summer to-do list, buying a new keyboard. We're gonna go mechanical, but silent, I think. And Little Miss Murder, do you define a minimum as the absolute lowest point reachable per contiguous water chunk? Good question. A minima, okay, this is probably the best way to define a minima in our use case. A minima in our case is a point where you have to move, where you can't move downwards from. A minima for us is a point where you can't move downwards from. Like in every direction you either move in parallel or upwards. Yeah, Fabric, that sounds doable. And if we can get it, like, that is something I definitely want to explore. Definitely want to explore. Because if you have like an elevation map stored in data in a nice way, you can like cut out a big chunk of this algorithm. And Fabric says, let's not argue about variable names. I love arguing about variable names. Wesley, mechanical always make more noise than a normal one though. Yeah, but I can imagine, like, my keyboard is pretty damn noisy, so I think I can go mechanical and downwards in noise amount. Or that's what I hope, at least. Thermal take Poseidon mechanical keyboard. It's garbage. I'd return it, but it's got a cigarette burn. I love the visuals of that. It's something with smoking at a computer that I've always find extremely romantic. I love it. It's just a romantic picture, you know. But I want to see thermal take Poseidon mechanical keyboard. Looks pretty damn nice, actually. There are mechanical keyboards that make no sound. It depends on the switches. Yeah, so I've heard. Oh, you want me to show? Yeah, let's see. Hopefully I get the correct one here. Thermal Take Poseidon mechanical keyboard. But, okay, so this one, let me quote Little Miss Murder. It's garbage. Some of the keys don't work reliably. They either bounce or ignore keystrokes. In her specific case, semicolon. It's this one. I mean, yes we are, yes we are. I'm dreading when I'm gonna go and very romantic indeed. I'm dreading when I'm gonna go to the store and try these different keyboards out. I'm gonna have such a hard time deciding. You have the blue one. Are we talking this one or? Keychron. What is Keychron? Oh, sorry, Fabric. Yeah, I don't know. Let's see. I don't know if I can make it bigger. We can get it like this. That's pretty big, right? I use an IBM PS/2 buckle spring keyboard for almost 20 years. Was it yellow as well? Oh yeah. Old computer stuff that becomes like yellowish after a time. Also very romantic. Also feels a little bit unsafe. The base structure of the keyboard makes a big difference as well. A full aluminium feels so much better than full plastic. I have a few different things I want from my keyboard. Like, I actually want to have a small keyboard, so I want to get rid of this part, but fuck, I use the numpad so much. So that means that if I get rid of it, I'm gonna have to work with these or do my custom bindings, and I don't know if I want to do that. Please don't romanticize the buckle IBM keyboards, they mess your fingers up. Is it because of that the keyboard is slanted in a weird way? That's a hard... I can't promise that I'm me. Like, when I see this picture, I want to romanticize it. What's up, Fluffy Zombie, by the way? I use an 8-bit DOE retro keyboard. Yeah, when we're talking keyboards, let's bring it up. 8-bit DOE retro keyboard. I can imagine that one bringing out the retro feel. We don't want to show prices and sites here. Spring bounce over millions of presses, it's not good for you. Is that so? Full-size keyboards are for people serious about productivity. Mini-field keyboards make me roll my eyes. Yeah, probably gonna have one with a numpad. I need that numpad. But then again, here I am, discussing keyboards instead of writing code. So maybe I'm one of those guys that don't rank productivity that high, you know? Check the... I'm still afraid of what will show up when I Google some of these things. So we're gonna go check the A.B.B mod 300 keyboard. And now we're talking real old times. Are we talking this one? But this one goes the other way. This one is it's big, but it shouldn't need to be big, right? The coating on the keys makes a difference as well. Slippery versus grippy. Oh, that is one thing I've never thought about. That is true. I'm not one of those that gets a lot of hand sweat. Not yet though, so that might come. I need to think about that now. Wouldn't you always want to have grippy though? Doesn't grippy feel better by default? And Little Miss Murder, hey, you're doing something and streaming it. That counts as being productive in my eyes. I appreciate it. Thank you. Intent is what counts. Yeah, most of the time, I would agree. I mean, think about the whack back that it causes against your fingers. So we're talking about the joints in the fingers. Is it about putting too much stress on the joints when there really is no need to put stress on the joints? I'm trying to understand, like, all of this is very interesting to me. I've never been one of those that put too much weight on a keyboard. But now when I'm started streaming continuous, I want to get a keyboard that is nicer to write on, but I also want to get a keyboard that is a little bit more silent. Yeah, probably not going to get this one. That's for sure. It doesn't even have a numpad, I don't think. Or is this the numpad? But nah. Spring clicks down and back again. It hits back against your finger. Yeah, you don't want that. I'm gonna keep that in mind. Don't you want it to... Okay, so there's a balance to get there. You don't want it to hit back too strong. And some cheap ones are usually either slippery or then grippy material that gets quickly worn out. Yes. Oh, yeah, that sucks. I would rather go with a slippery keyboard from the start than having grip that wears out too quickly. So just about the time where you are comfortable with the grip, that's when it starts to worn out. So you start to slip. Oh, so many things to think about. I'm just gonna add p height minus n height before I forget it. There we go. Oh, actually, that's not where I want to add it. We want to add it here. An absolute must-have are tits on a keyboard. Elaborate. Small bumps on a certain keycaps to keep touch typist registered. Oh yeah. So you can orient yourself without looking. You don't want to keep looking at that keyboard, right? And I didn't invent the term either. Yeah, that was what I was worried about when I was googling this. But yeah, tits on the keyboard. Must have. Like, I have it on my current keyboard. They are extremely small and located way down on the keycaps. So, which means that you don't feel them when you're writing or typing. But if you need to just make sure you're oriented correctly, you can just bring your finger down a little bit, and there you go. Fabric, I noticed that programming standing strains my fingers more and sitting strains my wrists. It's always the weighing pros and cons. What do I feel? What part of my body do I feel like destroying today? I've always romanticized the idea of laying down in bed and programming as well. But I don't even know how that would work. Maybe in the future, we will see. Okay, so the question of minima. This is where we're at. So a point where moving from that point never brings you downwards. That is what we want to get. So we have n height here, so we can check. So moving from P to N, do we move? If we move downwards, then is minima is false 100%. So that would be something like, I want to check it here as well. If n height is bigger than p height, or actually no. If n height is p height is bigger than n height, then we're moving downwards. And if this is true, then we definitely know that P is not a minima. So here we can set this one to false 100%. But so if we go through this whole double for loop right now and we get to the other side and is minima is true, then we know that we never went downwards, but we also know that we never went upwards. So I wonder if we want to do it like this, false. Else if P height. Okay, I'm just gonna show why we can't do it like this, or maybe we can. If P height is less than N height, is minima is equal to true. Andrew, by the way, thank you for the follow, appreciate it. And what's up? But Yeah, in this case, we actually have the fence post error. So currently we have it. Ish. Because, okay, we compare to a neighbor node or neighbor point. The neighbor point height is higher, so we set isMinima to true. Or actually, do we? If this is true, we always want to set minima to false. Actually, do we have it here? Do we have it here? And we could also, is this enough? No. Because we can move in one direction and the height is bigger or less or bigger, and we can move in another direction and it might be less, and then it's not a minima. Right. Little Miss Murder, are you planning to displace existing water when you terraform and adding terrain, or will you overwrite existing water? I thought about that a little bit earlier today when I was making coffee, I think. When we're gonna go an easy route, we're not gonna displace water, but we're gonna fill up. So if you dig a hole next to a lake, that hole is going to be filled with the same surface height as the lake. So the spread there is gonna be, fuck, we're gonna have to, let's put it this way, we're gonna spread the water, but we're not gonna remove any water from the original body of water. That makes sense, right? So we're gonna spread the water but not remove water if we dig a hole next to a body of water. If we add dirt into a lake, we're just going to remove the water from that point, basically. Andrew, the game is having a story, question mark. Yes. But it's very light, and we're at a stage where the story is only characters on a paper. We haven't started to involve it in the actual product yet. But it's basically a person wants to pivot whatever he or she works with and become a creature caretaker instead. So you are given a plot of land and a few loosely based missions around that. That's about it, basically. I don't know just yet if we're gonna go crazy with it, but we will see. It will evolve. Okay, so this is not enough. But can we do it like this? No, we cannot. Because this one might appear after. So yeah, we're gonna have to do this in a rough way, I think. But this is a little bit of a complicated situation. We're gonna have to... Or actually, can we just do... I'm wondering if we can do it with integers. We count how many neighbors are downwards, how many neighbors are equal and such. Actually, could we just add the heights, or we add neighbor heights and then we take can we do something with the average value? Don't think we can. Can we do something with we can probably do this in a very nice way. One sec. Okay, back. Let's see. Okay, so water level per contiguous. I'm sorry about my pronunciation there. Patch will always be fixed height, i.e., extending a lake creates water. Yeah, basically yes. What are the starting conditions for any particular water patch's height? It's the player. So the player pretty much decides how much water a certain point will have. So initially I don't know how the initial state will look on the garden. We might have some body of water initially. But from that point on, so from the initial state of the garden, the player will always decide where water will exist and where it will not exist. And yeah, that's right. You can't remove water by digging a river. That will always generate more water. But you can remove water by adding dirt. Let's see if I can get this contiguous. It's a balancing act when it comes to this water. We want to make it efficient, so when it is in a stable state, so pretty much most of the time, when it's in a stable state, we don't want to add too much calculations to it. Let me be less specific. It's a balancing act in the way of we want to give a lot of creativity to the player, or options, but we also want to make it work in a we want it to work in a semi-fun way as well, I guess. And then I don't want to yeah, let's just say that it's a balancing act between a lot of different stuff, and this is what I converged towards, making the water work this way. So this pretty much means that if you have a big lake of water at a high point in your terrain, and you want to make a river down from it to another lake, the player will just be able to dig. The lake will look as it did previously. Both the source lake will look how it looked previously, but now you will also have a river of water down to a smaller lake, and that smaller lake might get a little bit more water, right? Instead of having a big lake, the player digs a river, and then you dynamically drain the big lake, so you have to fill it up with water instead. That type also implies that we're going for a realistic way how water works, and that scenario wouldn't exist from the get-go, right? Because if you build a river from a lake up high to a lake down low, you're gonna drain the upper lake until it doesn't get over the edge anymore, and you will never be able to fill it more. It will always drain and drain and drain, and that's what we want to avoid. I hope this makes somewhat sense. Hopefully it will when we have it visually and gameplay wise in place. And it's pretty much that idea we have built this entire fluid solver around, which have made it possible to rely on a very simple solver implementation instead of something way more complicated. Okay, but this is not true either, but I wonder if we can do it the other way around. So basically what we had previously, if p height is less than true height and is minima let's see here. Let's see. Okay, so now it's true, but that's not true either. Yeah, I'm gonna have to get to the bottom of this tomorrow. It shouldn't really be that hard. Because I've got to run now. We're gonna run shorter streams this week as well, unfortunately, but the idea is that next week we're gonna do some long streams. I know. We have got a few things done today. Love the talks, appreciate it, appreciate every question, every input, and also the mechanical or keyboard in general discussion. I love it. Thank you so much for watching, everybody, and have a great one. My next stream this week will be on Friday, by the way. I won't be able to stream tomorrow. We're probably going to go longer than 2.5 hours next week, Fabic. Have a great one. Peace.